Laboratory preparation of hydrogen gas. So hydrogen gas is quite simple to prepare in the lab. All you need to have is a suitable metal and a dilute acid. Now what do I mean by a suitable metal? Not all metals are used in the lab for preparation of hydrogen. So over here we have a list of possible metals. I'm going to go through the list one by one and explain the reason why out of all these only one is used. Let's start with the first three. Now potassium, sodium and calcium are quite reactive. So just imagine a scenario whereby you're reacting potassium or sodium with hydrochloric acid in the lab. How explosive will that reaction be? It's going to be quite dangerous in a lab setting. So of course not. Moving on to the next one, magnesium. So magnesium can technically be used, but it's relatively expensive compared to other metals. So again, magnesium is out. Moving on to aluminium. Aluminium has a protective coating of aluminium oxide. Now, aluminium metal usually reacts with oxygen to form aluminium oxide. Aluminium oxide protects the aluminium metal from corrosion. So, it's very difficult to react the aluminium metal with a dilute acid unless first you go through the trouble of removing the aluminium oxide layer. Why bother? So, aluminium is out. Now iron, if you have impure iron, it's going to lead to the production of a mixture of gases, which is not what we are after. So iron again is also out. We are left with copper. What happens to copper? Now copper is a metal that is below hydrogen in the reactivity series. This simply means that it's less reactive than hydrogen. Now for metals to react with dilute acids, they need to be more reactive than hydrogen gas. Unfortunately for copper, it does not apply. So copper will not react with the dilute acid and therefore will not have production of hydrochloric acid. So the only metal that is usually used in a lab setting for the production of hydrogen gas is zinc. Now zinc reacts moderately with the dilute acids, leading to the formation of hydrogen. So when it comes to the dilute acids, you can use either dilute hydrochloric acid or dilute sulfuric acid. Either of these will give you the required results, but dilute nitric acid is not used, and the reason for this is because it's an oxidizing agent. So what happens is that the hydrogen gas that is produced is oxidized to water. Essentially, what you're going to get at the end of the reaction is not going to be hydrogen gas but water, which defeats the purpose. So dilute nitric 5 acid is usually not used. Now, if you use dilute hydrochloric acid or dilute sulfuric 6 acid, you're going to get correct results and you're going to get hydrogen gas. In our setup today, we are going to use dilute sulfuric 6 acid. So of course, these two are going to react, leading to the formation of zinc sulfate and hydrogen gas. Now you can clearly see effervescence, production of hydrogen gas is ongoing. So the hydrogen gas that is produced then moves into the U-tube. In the U-tube, we have anhydrous calcium chloride. This acts as a drying agent. So essentially, it's going to dry the hydrogen gas, ensuring that the hydrogen you collect is dry. Now, before we talk about collection of hydrogen, I want to mention something regarding a property of hydrogen. So hydrogen does not support combustion, of course, because the only gas that does so is oxygen. But when ignited, hydrogen burns with a pale blue flame, as clearly seen. Hydrogen therefore reacts with oxygen, leading to the formation of water. Water is going to be in vapor form. So if you want to collect liquid water, all you need to do is lower the temperature. How do we do so? By introducing a container having cold water. So the cold water is going to condense the water vapor into liquid water for collection. How cool is that? By the way, if you're enjoying this lesson, if you're finding this helpful, hit that subscribe button if you haven't done so already and smash that like button. Let's proceed. Now on to the properties of hydrogen gas. In case you're wondering, did she forget how we're going to collect hydrogen gas? No, I haven't forgotten. I'm going to discuss this under the properties. So number one, let's start with the easy ones. Hydrogen is colorless, it's odorless. That is, it doesn't have any smell, and it's insoluble in water and less dense than air. So let's start with the last two. Hydrogen is insoluble in water and it's less dense than air. Now these two properties determine the method of collection of hydrogen gas. Now when we talk about collection of gases can be collected in a variety of methods, but whichever method is used is usually based on the property of the gas that is to be collected. So in this case, hydrogen hydrogen can be collected in two ways, using overwater method and upward delivery. Now let's start with the first one. Hydrogen being insoluble in water can therefore be collected using overwater method as seen. So overwater method is essentially a method whereby you're collecting a gas over water as seen. So the hydrogen gas displaces the water, causing it to move out of the gas jar, and at the end of it you're going to have a jar full of hydrogen gas. So gases that can be collected using this method will either have to be insoluble in water, such as in the case of hydrogen, or slightly soluble in water. And of course this makes sense. If you have a gas that is soluble in water and you collect it over water, it will simply dissolve in the water, leaving you with literally a solution and not an actual gas to collect. Now another method that can be used for collection of hydrogen gas is upward delivery. So upward delivery is as such. It's used for collection of gases that are less dense than air, such as hydrogen. So essentially what happens is that the hydrogen gas, being lighter than air, moves to the upper part of the jar. It displaces the air downwards. So another name for this method is downward displacement of air, because you're essentially causing the air to move downwards, moving it out of the jar. And those, ladies and gentlemen, are the properties of hydrogen gas. Oh, I forgot to mention one. Hydrogen is a neutral gas. It's neither acidic nor alkaline. So by that definition, it has no effect on a litmus paper. So if you want to take a moist blue or red litmus paper, introduce it into a gas jar containing hydrogen, there will be no change. Okay, and therefore it's a neutral gas. And that brings us to the end of this wonderful lesson. See you next time.